Hi, my name is Joel Matthew. You are 15 CS177, and today I'm going to be explaining one of my programs from DS Lab. So I'm going to be implementing binary search tree. So in this, we are going to have the functions insert to insert the node into the binary search tree, and we are going to have the traversals pre-order, post-order, and in order for binary search tree. So let's see the program. We have the header files, and here I've created the structure of a name node, and we have the members data of type int, and left child and right child pointers of type node, and we create a object root which will be used as a reference pointer, and we initialize this to null. So uh, so let's first see the main program. So main programs is very simple menu driven program. So as you can see, we have the local variables, and the user asks for choice of operation, insert or traversal, and using switch case we implement each of these choices. So the first choice is to insert a node. So first the user is asked to insert a value. So we call the function bst, and we send the parameter value. So in bst, as you can see, the return type is void. So first we create a new node of type node, and then we assign value to data of new node, and the left child and right child is initialized as null. So the most important criteria of a binary search tree is that the left subtree should always, the members of the left subtree should always be of lesser value than the root, and values in the right subtree should always be greater than the root. So first, initially we check if the tree is empty. So in this case, root will be null, and then the first new node will be the first element into the search tree, and this will be set as root. Or else we call the recursive function insert bst. So in this we send two parameters root and new node. So the return type is void. So first the PTR arrow data is checked if it is less than root data, and if yes, then we go into the left subtree, and in the left subtree we see if the left child is null, then the root's left child is initialized as PTR, or else we again recursively call this function with the help of the root left child and PTR, or else we go into the right subtree, and root right child is checked for being empty, and if true, then root arrow right child is initialized to ptr. Otherwise we again call this recursive function with the help of the right child, root's right child, and ptr. And let's see, the second case is in order traversal. For in order traversal, this in order function will be called. So this also void, this also has void return type. So in this we check if temp is not equal to null, and this function is also a recursive function. So in this, first we go into the left subtree using this statement until we reach the leaf node, and then we print the value, and after which, if there's no more child, then it goes to the parent, and subsequently it prints the data, and then after reaching the root, then it prints for the right child. And next we have pre-order and post-order. So for this, these two functions are invoked. So these two are also recursive functions, but in this case, the only difference is that the data is printed first, and then we go into the left subtree, and after we finish the left subtree, only then we go into the right subtree. But in post order, first we go into the left subtree, and then we go up to, we check if there's any right child or right subtree, and if not, then we print the data, and subsequently, so essentially only the left subtree is first traversed, and the uh, all the root node will be the last to be printed in this case. Once we show the output, that will be very much clear. So, and the user is also given the choice if he wishes to continue. So let's see how the program runs. So the user is asked to insert uh, for his choice. So let's insert some values into the tree. So let's set some. So let's enter some 2, 3 values. So all these values have been entered into the binary search tree. So let's see each of the traversals. So let's first see in order traversal. So as you can see in order traversal, it is shown in sorted order. So from we show this in an increasing order fashion. So let's actually see pre-order next. So in pre-order, the root is first to be printed, then followed by left child, and then followed by right child. So 17 is printed first, which is the root. So let's check for post order. And as you can see, we first traverse into the left, and then we traverse into the right, and then we print each of the values. And the root is always the last to be printed, as you can see. So do you want to continue? No. Thank you for watching this program.